All right, we're on Math 2, Unit 11, Lesson 4, multiplying special cases. These tend to be ones where we have the same group of terms and they're squared, and that's kind of the lesson for the day. So let's look at the first one, for example. I'm going to go ahead and just rewrite the expression like this by getting rid of the squared sign because it means the same thing. And then I go back to the previous lesson and say, well, now let's just go ahead and multiply it out. Y times y is y squared. Y times 1 is plus y, another plus y, and then plus 1. I'm going to combine the middle terms together to leave me with y squared plus 2y plus 1 for my solution there. Let's look at number 5. Number 5, I'm going to have the whole thing, again, times 4x plus 1. So I'm going to write it like this because I'm already squaring it. So again, 4x times 4x is 16x squared. I have then, because I'm just squaring it, I can start to see the pattern. I'm going to have a 4x plus another 4x. So 4x plus 4x is 8x. On the outside, 1 times 1 is 1. So I did a little bit of shortcut there because I know I'm squaring it. I know I'm just going to basically take this and double it up. So look at this next one here, for example. If I have 3n plus 2, I know that by doing those two together, I have 9n squared. I know that 2 times 2 is going to be 4. The question is, what about my middle term? Okay, well, the middle term is going to be 3n times 2, which is 6n. And here, 2 times 3 is another 6n. So 6n plus 6n gives me 12n in the middle. Okay, so you're just really combining those together. So you can write them out this way and combine, or do a little mental math and combine. It's up to you. Next one here, 7v minus 3. I have 7 times 7 is 49v. 7 times negative 3 is a negative 21v with another negative 21v. And negative 3 times negative 3 is a positive 9. I'm going to combine my middle terms. Negative 21 plus another negative 21 is a negative 42v. And my outside stay the same, like so. Number 10 and 11 are great problems. Again, type of thing you might see on your test at the end of this unit. Okay. So it says, find an expression for the area of the shaded region. So the shaded region is the dark part, and write it in standard form. So to do this, I need to basically figure out what is the area of the shaded region, and then I'm going to subtract the part that's been cut out. So the area is going to be length times width, or x plus 8 times x plus 8. Okay, that's my area, the whole thing, and I'm going to subtract from that the area of the little bit, which is x times x. Okay, that's my goal here. That's the big one, shaded, minus the little square on the inside. Okay, so here we go. We have x times x is x squared. X times 8 is 8x. X times 8 is another 8x. And 8 times 8 is 64. Minus x times x is x squared. Now at this point, I can combine like terms. X squared minus x means the x's go away. 8x plus 8x is 16x, and we have 64 remaining. So my answer is going to be 16x plus 64. Same type of thing is going to be true over here for number 11, right? We just have x plus 5 times x plus 5 minus the inside square, which is x times x. Alright, so looking at it again, we end up with an x squared here plus 5x plus 5x, 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 plus 25 minus x squared. And again, those will cancel out. So I'm left with the combination of 5x and 5x is 10x plus 25 for that one there. Okay, let's flip it over and look at the back side of 11.4 today. This first part, I'm not quite sure what they wanted you to do or how your teachers would cover this or not. Let me just show you one idea for mental math of how to do this. Perhaps you want to look at something like maybe the box method. 52 is the same as 50 plus 2, 50 plus 2. Now at this point I'm not doing mental math because I'm actually writing this out here, so I get that. But maybe mentally this is how you look at it. 5 times 5 is 25 with 2 zeros. 50 times 2 is 100. 50 times 2 is 100. And 2 times 2 is 4. So now I have some very manageable numbers. I have 2,500 plus 200 plus 4, or 2704 for 52 squared. Again, I'm not quite sure how they want you to figure that out. I'm not sure what your teachers are telling you. So again, if I did the same idea for 18 and 18 squared, I could break 18 up into 10 plus 8, 10 plus 8, and I have 100, I have 80, I have 80, and I have 64. So 100 plus 100 plus 80 plus 80 is 160, plus another 64 gives me 324 as an answer there. So see what your teachers are asking you to do. I'm not sure what they're looking for. I know most of you probably just go and you punch in your calculator and say, there's the answer. But the idea is to figure out how could you break this number apart into something more manageable. 70 times 2, or 70 plus 2, and then solve it out that way. All right? So that's fine for now. Let's simplify these next expressions here. Again, more special cases. These are ones where, unlike the last one where it was plus plus, we have plus and a minus, which usually is pretty nice. It usually means that the inside terms are going to disappear on us. They're going to cancel out. Let's see how that works. So x times x is x squared, and then x times negative 1 is negative x. 1 times positive x is positive x, and 1 times negative 1 is negative 1. So negative x plus an x, those essentially go away. So I'm left with x squared minus 1. Alright, same thing down here. S times s is s squared. Then I have a plus 13s minus 13s, and 13 times 13, I don't know what that is 39, 39, 9, 12, 429, lucky us. And we have a negative 429. So my answer, because those cancel out, is s squared minus 429 for that problem there. Alright, let's look at one more real quick. For number 25, we have 4d times a 4d, which is 16d squared. Because they're going to be a plus and a minus, I know the middle term is going to cancel out, so I'm not going to bother doing it. I'll just multiply the last terms. 6 times negative 6 is negative 36, and I'm done. So it's kind of a shortcut way. If you see, it's the same deal. It's just the first times the last. So it's your FOIL method, except we got rid of the O and the I. It's just FL. All right. Not going to write mental math there. Simplify these products. Same idea. I have s plus 3t, so I'm going to go ahead and write s plus 3t here, and then use my distributive property again, or FOIL method. S times s is s squared. S times 3t becomes 3ts. Okay? Now here, I get the same, plus 3ts, and 3t times 3t is 9t squared. Oops, I don't know why I wrote a 2 there. Sorry about that. That should be an S. S, sorry. Now these are the same. 3ts, 3ts. This is like cat, cat, or dog, dog. They're exactly the same letters with the same exponents, so I can combine them. So I have s squared plus 3 plus 3 is 6ts plus 9t squared. Let's do another one like that. Let's go ahead and do number 33. 9f squared times 9f squared becomes, careful here, 81f to the 4th power, because I add up my exponents. 2 plus 2 is 4. 9 times a negative 4 becomes negative 36, and this one is f squared g. There's my f squared and my g. And this also becomes a positive 36 f squared g. And then 4 times negative 4 is a negative 16. G times g is g squared. So a negative 36 and positive 36, and they're the same group of terms. Cat, cat, dog, dog will cancel each other out. So I'm left with 81 f to the fourth minus 16g squared for that solution to number 33. Alright, so we're going to pause there for now. 35, I will say, is another great problem. It says there's your volume here. We have the radius, the height. It says find the volume of a cylinder with a radius x plus 4 and a height of 5. And then we have to distribute everything out. So if I was to rewrite that, my volume is equal to pi times my radius, x plus 4, and it's squared, times the height, which is 5. Okay, that's my basic formula. So when I write that over, it looks a little bit like this: x plus 4 times x plus 4 times 5. And I have to kind of do each part again and again and again until I get everything spread out. You'll end up with a pi in all of your terms as your answer. You'll also end up, don't forget, centimeters, with a centimeters cubed as your term at the end as well. So you have to do the math here, but that's the way you set that one up. Okay, and that's it for today's lesson. Thanks.